Hi, Austin. How you doing? Hanging in there? All right, let's do it. So I'm Lynn Langit. I'm an independent architect. I work with all the public cloud technologies, and I'm going to talk about SQL queries that are serverless. So it's been interesting watching this conference, hearing all about serverless compute. I think I'm the only presentation, maybe there's one or two more, about serverless data. And I think, as an architect, the changes coming to the world of data are actually as groundbreaking as I see in compute. So to that end, let's do this. Let's say you had 50 bucks. What can you do with 50 bucks? Well, what you can do with 50 bucks is you can process 3 terabytes of data. How quickly do you think we can do this? Anybody got any guesses? Go ahead, what do you think? 30 minutes, okay. So we've got a SQL query here that's kind of hairy. It's kind of a hairy, and this is biology stuff, so I know we're not biologists, but I'll just kind of scroll down and show you the SQL query. It's kind of hairy, kind of gnarly. How much data am I doing this on again? 3 terabytes. And how much is this going to cost me? 50 bucks. All right, so let's see. How long is it going to take? It took 1 second because I did the easy query. I need the hard query. Yeah, I need the hard query. So let me take this one. I need the hard query. Where's the hard query? This one, I think. And if not, yeah, probably because I just ran it. All right, well, that just really steals my thunder, so I'm going to have to show you my demo, my recorded demo. So query, we're going to query it, 3 terabytes, and it is complex SQL, and that's what I get for caching it. It's took 21 seconds. So that's kind of amazing for 50 bucks. And there's no servers. It's pretty much of a game changer. Now I know the title of this talk is Athena, so you're probably wondering why am I showing BigQuery? Well, the reason that I'm showing BigQuery is because Athena is the new guy in town. Google has been around with this for 7 years. Since 2011, and they really came ahead of their time. I still find that there are a lot of people that don't even know that BigQuery exists, and so I wanted to show you kind of the first player in the space, the first mover. So the technical aspects behind this is you load data in the format of CSV, JSON, or Avro, and then you query it. Now BigQuery is different than Athena in that you have to do a load. They also have public data sets, like I showed you, that are terabytes and terabytes of data. You pay by the query execution, so it's truly serverless. Now, one of the challenges with BigQuery has been, because it's almost magical, some of the teams that I worked with did incur costs because they were just using it as if it were a local relational database server, because the interface was just so easy like that. So Google has put in some cost controls, some alerts and quotas, which are really, really important. Because BigQuery's been around for a long time, I'd be remiss if I didn't talk about the state of BigQuery as I compare to Athena, because Athena is a very new service. And if you're going to move into the world of serverless SQL, it's really important to understand the state of the product that you're working with. BigQuery allows partitioning tables by date and only by date. You can stream directly into BigQuery, which is really interesting. One of the architectural patterns that we're seeing more and more are events. And BigQuery actually supports direct event streaming without an intermediate set of functions or lambdas, which is the pattern that you'd use for Athena. It supports data manipulation language, so you can actually do inserts and updates against the data that you've stored in BigQuery. It includes JSON functions, supports for UDFs, so your own functions. It has JDBC and ODBC drivers, granular security, cost control, and integration with GCP. It's a very mature product. That being said, this talk title is not BigQuery, it's Athena, so we're going to move over there. So the architectural pattern that I'm seeing around serverless SQL looks like this. At the bottom layer, you have a data lake. That generally is some sort of object store like S3 in Amazon or Google Cloud Storage or Azure Blob Storage in Azure. And then you have layers of SQL query on top of it. Now, the level to which this has been implemented, it differs by the different cloud vendors, and I think is actually a really important consideration when you're trying to figure out how to work with these products. As you can see from the diagram, some of the vendors allow you to directly visualize what's in your data lake. Other vendors have an exploratory layer, the blue box, and that would be the BigQueries and the Athenas of the world. Other vendors have managed Hadoop and Spark, and that's for big transforms, and then other vendors have warehouse implementations. So BigQuery's been around, and it's been disrupting a lot of my clients. I work with both enterprise and startups, and I had Werner's ear. This is not a Photoshop picture, this is an actual picture. I'm what's called an Amazon community hero, and this is at the last reInvent. They had a special party for all of us, and there's me and Terry, who's another hero, and two of the user group leads from Korea who were there. And we actually have had ongoing conversations about some of the product differences between the vendors, and Amazon listened. So at reInvent last year, they announced Athena. Athena is a serverless SQL query solution that is similar to BigQuery, but not the same. And that's one of the messages that I want you to take from this presentation. Because if you have worked with or experienced BigQuery, you probably have an expectation that maybe this is just a, gosh, that was a great service, and so, we're going to just make a version of it. And there are some really important implementation differences that if you're going to work with these services, it's critical for you to understand. So when you first look at them, because of course now I have to show you the console over here, they look, there's BigQuery, there's Athena, right? Different colors, different logo. So you have table abstractions to the left, you have query window on the top and results on the bottom. Table abstraction to the left, query results, and query here and query results on the bottom. So they look surprisingly similar, but the implementation is actually very different, even though they're both serverless and SQL. That's where they're the same, but beyond that, they differ. So how do they differ? Well, let's see. So Athena has a different method of working with it. For Athena, there is no load step. You simply point your descriptor or your metadata to information that you have stored in an S3 bucket. So the first level of working with Athena is put files in an S3 bucket. Now the type of files and the way that you work with those files is actually really, really important, and again, differs from BigQuery. The second thing is in the Athena interface, you then define a table schema, and you do this using Hive syntax, and I'll show you an example in just a second. It's create external table, and then you put in the column names and the data types. What you're doing is you're defining a schema on read. You're not physically copying the files from one object store into another the way it goes in BigQuery. And then the third part is you're running an ANSI SQL query. Now, a key difference in Athena between Athena and BigQuery is you can use Athena ad hoc against a number of types of files, so CSV, text, so on and so forth. However, if you use optimization techniques, you can save a substantial amount of time and money, so 30 to 90% or even more, by doing one of three techniques: compressing your file, partitioning by any key, or converting to a columnar format. So there's really two levels of working with Athena. One is just ad hoc. I've got a small amount of data, some gigabytes worth of data in S3, and I just want to do some interactive query on it. The other side of Athena is I have a huge amount of data, and I'm really concerned about optimization of cost and performance, so I'm going to spend a little time up front preparing or ETLing my source files that are going to be in my bucket, okay? So before I get into the details, let me just show you, and I'll be a wuss here and show you from my recorded demo, just because it's easier. So this is all BigQuery stuff, partition, da-da-da-da. All right, blah, blah, Athena. So in Athena, you start by creating external table. So you're just having the metadata here. You're not importing any files. It's really important to understand. And then notice on line 22, 23, and 24, you're saying the method that you are serializing. So in this case, you're using Hadoop Hive. And then you have certain properties, and these properties can include regex patterns, which will delimit the file, basically process the file, also compression and other attributes. So once you do that, then that's going to make that table available in the left-hand column. So then you just run the select clause to verify that you've got it. And then in this one, I just pulled off of this blog post, and I pulled from some sample logs to show you the optimization process. So this is just building the simple table, and then I already built one table. So the second table, I'm building this one as Parquet. Parquet is a storage format that is columnar, so stored in columns rather than rows, and it is one of the methods for optimizing files. So this table is defined in Parquet, and it's also compressed using snappy compression. So going on here. So there, I'm defining it in my interface, and then I'm querying it. And then also this table was created with partitions. And one of the aspects of working with Athena is you have to load the partitions with this repair table command. And you'll actually see it in the interface after you create a table with partitions. In order to load the partitions based on the partition key, you have to run this command. Then you run that, and then I'm showing the partitions. Showing the partitions. You can see them down there. They're by year and month and day, so by day. And then this is my, gonna go there. Then I'm on my Parquet table right there, and I'm querying my Parquet table versus my regular CSV table is really what the point of this demo is. So inside of here, I'm querying this thing, and it comes back 2.5 gigs in 11 seconds. And then I've got an ELB. I have to look really close here, sorry. There. ELB logs, raw native. Well, you can tell I did this late at night. There, just gonna run that. And then that's going to be slower. So there, ELB logs, raw native. In fact, so much slower, I actually canceled the query. So what has happened is when I've created the table definition, I've taken the original files that were in the bucket, and I have defined them in an optimized format, Parquet, and then here, I'll just stop so you can see that. So the first one, you can see, actually, I canceled it at 82 seconds. It was 368 gigs. The second one was 2 gigs in 11 seconds. So it's kind of pretty obvious what using an optimized file format, in this case Parquet, using compression, snappy compression, and using partitioning can do for you. Really, really important. When I talked with the Amazon team, when I told them I was going to come here and talk to you, they said really emphasize this to the audience, because being a new service, it's really, again, 2 levels of working with the service. So hopefully that makes sense. So now details. So under the hood, BigQuery uses a technology called Dremel. If you want to understand how that works, Google has a white paper on it. Athena uses Presto, which came from Facebook. There's just different implementations if you're a real nerd and you want to read that. Both are serverless and auto-scaling, so you have no clusters, no replication, no log shipping, none of that sort of traditional DBA stuff. It just scales up. You just pay by the amount of data scanned. Athena supports joins, windows and arrays, standard SQL stuff. Athena supports, and this is a difference again between BigQuery, CSV, JSON, ORC format, Avro, Parquet, and you can pick up your CloudTrail logs, which is kind of cool. There's a JDBC driver, and it's supported by QuickSight already, so you can visualize. A use case that I had actually with a customer in a startup in LA a couple weeks ago is they were a BigQuery customer, and I told them about Athena, and they had infrastructure on EC2 and Docker and that kind of stuff. And they did this use case with pulling in their CloudTrail logs And we're able to get it up and running, within a couple of hours, and then, looking at it in QuickSight, which was kind of a cool use case. You can use S3 IAM permissions, and you can encrypt. That was announced, I think, last week. They don't have UDFs or stored procs yet. The compression for Athena is gzip, LZO, Snappy, or zlib. And then you can stream your results to the console and store them in S3 if you want. Now that's streaming out. To stream in, unlike BigQuery, which you can just change the API call to say streamed, you have to build that out with a Lambda out of Kinesis, usually, putting the information into your S3 bucket. So hopefully that makes sense. A little bit different in the architecture as of yet. So yes, there's these two services. There's a lot of details about them. I would think most of you guys don't yet use either one of these services. So why am I here at Serverless Conf? Why did I choose to talk about this? Because I'm finding that serverless SQL queries are having usefulness beyond just startups exploring behavioral data. And I think the fact that Amazon has decided to create the Athena service really supports that, because although Amazon is building for all customers, they're tending to build a lot of services now that support enterprise. This is a group that I actually worked with. This is a contract that I worked on, an Amazon contract last year. It's an interesting group, actually. They do what's called mob programming. So this is how you program there with those huge monitors, which has ruined me forever, because now I'm going to have to buy some of those huge monitors for home use, because I just have to. But anyway, so what I found is in this team, as they were moving towards a modern architecture with serverless, with Lambda, they wanted faster feedback on some of their things like their logs. And so we were looking at different methods for consuming and working with these pieces of big data and behavioral data that I wish we would have had Athena over the past year. And in fact, even though I'm not working with this team anymore, they were really excited and already using the Athena service to look at their logs as well. So I'm just seeing more and more use cases for serverless SQL than I had in the past. So thought I would share. So again, mechanics about this. You work with Athena by creating the external table. Then you have standard SQL. You can add partitions. I know I have a developer audience here, so that's what the JavaScript connection library looks like. So even though it's a new product, Amazon's quite good at, even when they release new products, having a mature set of tooling around it. And there's also, Java libraries for those of you who are, suckers for pain. I don't know. Anyway, kidding. So I mentioned costs, and costs are astoundingly low. So you have the economies of scale that are comparable to Lambda for compute. So both Athena and BigQuery are priced comparably, $5 a terabyte scanned. Now the storage of data is slightly different. Of course, you're charged for the storage in S3, and this is kind of a rough estimate. And in the BigQuery case, you move the data into BigQuery. Loading and exporting data is free. So, and again, just to drive the point home about the Athena optimization potential, if you're using true big data, if you're going beyond the exploratory case, I'll just kind of give you the highlights here. If you just started with 3 terabytes, it'd be $15 for the query, right? And then the middle there, if you do compression with gzip, you could get a 3-to-1. And then if you subsequently converted to Parquet, you could get an additional 3-to-1. So that would reduce your cost from $15 to $1. And you can kind of see the economies of scale there. So really important. So speed. The reason I have a TBD on this is because, well, first, I have an NDA with my client, so I can't give specifics. But I did a bunch of perf testing with a startup in LA in preparation of coming out to serverless, because I wanted to have some information for you from the real world. And this customer has been, at this startup and a previous startup, a real heavy user of BigQuery, so much so that they had to go to Google and have their slot limit raised, which is pretty substantial for BigQuery. And they've been working with Athena now for a couple of weeks, and their initial feeling is BigQuery is faster for some queries, and Athena is faster for other queries. So I was actually kind of surprised. My expectation was I thought BigQuery would probably be generally faster because it's a more mature service. But they said for different types of queries, and queries particularly, not a big surprise after what the product team told me, using optimized file formats like Parquet, Athena was running faster. So I'm going to be continuing to do perf testing on this. For those of you that might know some of my other education work, I love doing perf testing on data workloads, and I'll publish on my blog. So just follow me on LinkedIn, Twitter, all that kind of stuff if you're interested in some real-world perf testing results, because with this one client, they said I could publish eventually once we get through it a little bit more. But as of right now, initially, similar, which is good news for us. So use cases. What would you use this thing for? Why am I talking to you guys at Serverless Conference? Well, the obvious thing is explore and experiment, which that goes to some of the talks we've been hearing. I don't know if you were sitting in this room hearing the talk from the Agile guy. I thought that was a really great talk, talking about experimentation. The Nordstrom people talking about experimentation, sort of a common theme in modern software development. So experimentation around data, I think, is a newer concept, especially for enterprises to think about. But if you are instrumenting your applications, you're A/B testing, you're getting all kinds of behavioral data, how can you party on that data faster without disrupting, let's say, your relational database infrastructure? Well, Athena's great for that. Athena's great for that. Data warehouse replacement. Wow, that's kind of scary, huh? Data warehouse replacement. That is the route that Google is going down. They've been adding a bunch of enterprise features to BigQuery, and they're actually pushing it forward as a data warehouse replacement. I can't say that I've actually put that into production yet, but I have been asked to build POCs because of the cost difference. And then the other use case is ad hoc reporting. So you might have remembered that earlier slide that I showed that showed sort of the general pattern. It's really interesting how Amazon has built to the general pattern and actually added to it, as only Amazon will do. One of my jokes about Amazon is they release services so frequently, I literally get up in the morning and refresh the console just to see what kind of day I'm going to have. It's like, okay. And last week I refreshed the console and I found a new service that relates directly to this talk. It was released last week. It's called Redshift Spectrum. And so we'll get into that in just a second, but that was literally released less than a week ago. So at the top level, we have our visualization tool for serverless SQL, which is QuickSight. The bottom level, we have our data lake or our persistent store. In some ways, our database becomes S3, which is a little crazy if you have a background like I do, very traditional DBA background. It's kind of sounds heretical to come out of my mouth. The database is S3, but it seems to be. And then on top of it, you have these different query layers. So Elastic MapReduce or Hadoop Spark, that's more of an obvious use case. That's when you have big batch processing to do. And of course, you can use Spark SQL for that as well. Athena is for the ad hoc querying, and Redshift is for more persistent querying. So this is the way the product team says it. Oh, let me actually, I'll put it into a pipeline in a second. And Spectrum is an extension to Redshift that allows you to do Redshift SQL queries against data stored in S3, which takes a little minute to figure that out, because isn't that the same thing as Athena? So we'll go into that in just a sec. So anyway, so again, pulling this into a business use case, where would Athena plug in? That kind of helps us to think about these different products. So you've got your data sources, they go into S3, you maybe do some heavy lifting, you transform your CSV files or whatever into, let's say, Parquet files using a Spark job because you have tons and tons of files, and then you put the new files into the second S3 bucket, and then maybe you load them into your data warehouse and you visualize them. Well, notice where Athena is here. Athena is put onto the first load, so you can do a quick look at the files, a quick evaluation. You can look at data quality. You can derive some meaning maybe more quickly than waiting for the information to go through the pipeline. And then Athena is put on again after the data has gone through one quality check. So it's really a new way of thinking about evaluating data and what's kind of the high-level thing. Why are all these services needed? They're needed because we have a lot more data. So two domains that I've been working in that help me to understand the need for these kind of services are IoT and bioinformatics. So I just finished a big IoT project where an enterprise that had hundreds of thousands of devices, Wi-Fi enabled them, and used the Amazon platform to gather not only just the commands, but we also started doing A/B testing on data of that volume. So they went from basically just having transactional data to having exponentially more data, and really were overwhelmed. Their couple DBAs couldn't put up SQL Server, Oracle servers fast enough, so how are they going to process the data? So modern data pipelines like this is how you deal with data workloads of that volume. In the bioinformatics space, I've started working with some commercial and research firms on optimizing genomic sequencing pipelines, because much to my surprise, when I started looking at the domain, I found out that common pipeline optimizations that I see in some verticals like ad tech are not being yet applied as globally as I'd like in bioinformatics. It's kind of a personal story. A friend of mine got cancer and she couldn't get personalized treatment. And it's been really interesting to work with bioinformatics pipelines and to start to apply serverless compute and serverless SQL to the pipelines, and to be able to allow the biologists to get feedback on the effectiveness of personalized drugs much more quickly. It's very, very satisfying. So when you have huge amounts of data is when you need to look at partitioning out the services that you work with it. So that's what I was looking for. So this is what Amazon says. Athena is best for ad hoc SQL queries. And in that case, I think a lot of times you don't do anything with the files. You just put them in there, and it's just gigabytes data, and it's a small amount of money, so you just party on the data. And Spectrum is used for frequently accessed, or designed to be used for frequently accessed and highly structured data stores stored in S3. So when you are going to incorporate this, let's say, genomic data into your report, and you don't need to access it so frequently that you want to put it in your Redshift cluster, it would cost too much money, it's an extension of Redshift. Very, very interesting. It actually spins up additional compute nodes that, to your core cluster that then will do Redshift SQL queries against S3. So very interesting use case. So Redshift Spectrum, again, just announced last week. So it supports Parquet, text, sequence file, and RC files, so a small subset of what Athena supports. But notice Parquet, that's something to kind of take out of here. Parquet seems to be emerging on the Amazon ecosystem as an optimized file format, very important. Compression, gzip, snappy, BZ2. Only server-side encryption for Redshift Spectrum. A couple weeks ago, the Amazon team announced that encryption is fully supported for Athena, which is very important for all of us that are protecting our data. And then I was reading and working with some source data, and they had some tips about working with Spectrum because of the way Redshift works, to break files into equal sizes between 100 megs and 1 gig. And then you can actually make use of the schemas that you've created in Athena. So you remember back in the beginning of my talk when I showed the create external table, you can actually query that then with Athena or Redshift Spectrum if you have a Redshift cluster available. And to be clear, Redshift is not serverless, Redshift Spectrum. It's not serverless. You have to have a server up, but it's part of this ecosystem. So where do we have serverless SQL? In which ecosystems does it fully exist? For ad hoc SQL querying, we now have choice in terms of Amazon and Google. Both BigQuery and Athena are fully serverless. They scale automatically, they support ANSI SQL, and they're amazingly cheap and fast. So I'm recommending really to the majority of my clients to at least take a look at them for evaluating log data. That's a good starting use case. At the data warehouse level, it's really interesting. Google is adding all these features around BigQuery and advocating it as a serverless data warehouse. I haven't seen adoption be huge yet, but again, serverless is driving our industry, so it's something I'm paying attention to. Redshift, of course, is server-based at this time. Batch transformation for Elastic MapReduce, Hadoop, Spark, or Dataproc in the Google ecosystem is server-based at this time. And streaming SQL, serverless SQL, is a manual process for AWS. As I mentioned, you have to create a Lambda-based architecture to listen to Kinesis streams. For BigQuery, it's already enabled. And that's actually a really important aspect of this, because as we've been hearing, and I started my presentation with, what is data? Data is really becoming event streams. That's clear pattern, really reinforced by so many of the talks in this conference. So this idea of streaming serverless SQL is where we're going. We're not yet there, though. So, to that end, question. Is there serverless Spark SQL? If you're not familiar with Spark, it's a distributed compute based on the Hadoop paradigm, and it's in memory, and it scales really exponentially. So does this exist? Well, there's this company called Databricks, and Databricks is where the Apache Spark committers live. And they have this product called Catalyst. So it uses Amazon Snowball. Have you heard of Snowball, the truck? And Snowmobile. So they have this use case in Australia. So what they're talking about here, it sounds kind of crazy, but if you literally drive a truck to where you need to do the compute on the data, they're advocating that with their API, this can be 66 times faster than internet, 32 times cheaper than internet. And they say, well, you know, if the query plan includes no intermediate transforms, it's possible to dispatch Snowmobile jobs that write directly to the output. This cuts cost and latency, removing the need for a cluster. In fact, thanks to deep learning on Spark, future transfers could be serverless and driverless. Well, only on April 1st. So some things are still hype, and serverless Spark SQL is one of those. But serverless SQL queries are reality on Athena or BigQuery. And I hope I've given you some things to think about. I'll be continuing to write and work on this, so if you're interested, follow me on Twitter, and I'm Lynn Langit. Thank you.